Okay, this video is going to go over the homework for tonight, October 27th. It's basically to finish up our work with complex numbers. So we're going to do this. We look at two binomials multiplied together. A lot of us know that as FOIL. So we're going to multiply 3 times 4. That's going to be 12. 3 times I is plus 3i. 2i times 4, negative 2i, excuse me, is minus 8i. And then negative 2i times I is minus 2i squared. And I'd like to write that out just like this, and then I'll deal with this in a minute. So now I'm going to combine things. That's 12. These two, get a different color here. 12 and these two are going to combine together to be minus 5i. Now this is where I squared is the same thing as negative 1. So this basically is negative 2 times negative 1, which is plus 2. So I put plus 2. And now I go back and look at the situation that I have, and I've made it a very simple problem. Here's my like terms, 14, and then minus 5i. And that will be the final answer to that one. The next problem is a little more challenging because we have a fraction, and the bottom of our fraction has an I in it, which is not allowed, so we're going to get rid of this. Now the problem is we need to multiply by the conjugate of 5 plus I, which is 5 minus I on the bottom, and then that means we have to multiply on the top, otherwise it won't work. So this basically, we're doing it this way. So now the numerator is going to be 3 times 5, which is 15. And then 3 times negative I is minus 3i. And the bottom of my fraction is going to be 5 times 5 is 25. 5 times I is minus 5i. And then this is going to be here plus 5i. And then last one, I times I is minus I squared. So that becomes 25. These will cancel. I squared is negative 1. Minus negative 1 is plus 1. So the bottom of my fraction becomes 26. So now I simplify that by making it into two fractions. 15 over 26 minus 3 over 26i. And that's how we leave the final answer, because we can't reduce either of those fractions. Next problem here caused a lot of concern for people because it looks a little bit all crazy. We got i's and I to the 34th and plus and minuses. Let's break it down into simple math here. We're going to say I to the first is I. We have to know this pattern. I to the second is going to be negative 1. These are definitions right here. Now we use those facts to figure out I to the third, which is negative I to the second times I to the first, which is negative I. And I to the fourth is negative I to the second times I to the second, which is negative 1 times negative 1 is 1. So once I have this thing here, the pattern continues. So I to the fifth, if I were to continue, would just start over again as I, and then I to the sixth is going to be negative 1, and I to the seventh is going to be negative I, and I to the third, I to the eighth is going to be 1, and it just repeats that pattern over and over and over again. So without using that thinking pattern, if I say I to the fifth, I think of that I to the fourth is closer, it's one more makes it I. So this becomes, so I to the fifth equals I. So the first thing becomes 5I. Now I have an I to the 10th. I to the 10th, I can keep writing it out if I want, just go 2 more, or I can say I to the 8th is 1, and I have to go 2 more to get to 10. That makes it the same as I to the second, which is negative 1. So now I'm going to have 5i plus 3 times negative 1, which is going to be 5i minus 3. And then I'm going to look at I to the 34th. And I do that pattern of all multiples of 4. So 4, then 8, then 12, then 16, then 20, 24, 28, 32. 36 is too big, so 32. And 34 is 2 more than 32. So it's the same as I to the second. So that's going to be negative 1. So this is going to be minus 4 times negative 1. But negative times a negative is positive, so plus 4. And then the last problem, I'm going to look at last part of the problem. I put I to the 23rd. 23, if I use multiples of 4, that's going to go up to 20, and then 24 is too big. So from 20 to 23 is 3, so this is going to be negative I. So that's going to be minus 2 times negative I. Negative times negative is positive, plus 2I. And now what I have is a very simple problem. I combine like terms. So that's going to be 7I. And then these guys, 7I plus 1. We put the I part at the end, so the answer will be 1 plus 7I. That's what I'd like to see for the answer. Okay. The next problem, number 6, is kind of confusing because we have i's, but we also have square roots of negatives, which are I. Now, we know the square root of negative 1 is just the same thing as I. So basically what that means is when you have a negative inside of a square root, it becomes a I outside. So this is negative 4I minus I times the square root of 5, but the square root of 25. But the square root of 25 is I, so negative 4I minus 5I, because the square root of 25 is just 5. That's negative 9I. The mistake most people make is they look at this negative and say negative times negative is positive, but that's not the case here because this negative is inside of the square root. To come out, it becomes a positive I. Okay. 5I to the third. There's a couple of different ways to do that. One way is to realize what something to the third power means. It's 5I times 5I times 5I. Now, there's a couple of ways to do that. One method would be just to, as when we multiply 3 things together, we do it 1 at a time, or 2 at a time. Do these 2 together, that becomes 25I squared, which is 25 times negative 1, negative 25, and then times 5I. So negative 25 times 5 is a negative 125I. That would be my final answer. Now, there are other ways we could have done that. We could have here multiplied 5 times 5 times 5 is 125 times I to the third, but I to the third is negative I. 125 times negative I, which is negative 125I. Same thing as that. We could have also distributed this in here. So it would be 5 to the third times I to the third, which again is 125 I to the third, and that becomes that, which becomes the answer. So either way, we get that. As long as we're following our mathematical rules, we're going to get to the right answer. The next problem is one that confused a lot of people when it's actually one of the easiest problems. The directions say add. A lot of people see the parentheses here and know that we've constantly done our FOIL thing and they started FOIL, that we don't want to do that. This just means add them. So basically, I'm going to write this 5 minus 7I plus 3 plus 4I, because this is no coefficient in front of here, it's just 1. So now I combine like terms. 5 plus 3, that's 8. Negative 7I plus 4I is minus 3I. That's it. We're done. Let's not make that too hard. Okay, multiply here. We have a binomial times a monomial. Now, usually we see this in the front, but in this case it's in the back of the fraction. It doesn't really matter. It goes in like this. That gives you 18I. And this here is going to give me plus 12I squared. But I squared is negative 1, so 18I minus 12. And now put it in the right form would be negative 12 plus 18I. And that would be the answer to that problem. All right. As we move on, this one confused a whole bunch of people. Let's just break it down to what we need to know. When we have a square root times a square root, we can multiply them together. But we can't do that when there's negatives in front. So this is, I'm going to write this I to the 9th. That doesn't change. I'm going to change this part of the fraction. This part of the fraction I'm going to change to be I times the square root of 2, because that negative comes out as an I. I to the 6th, that stays the same. And then I to the 18th becomes, square root of negative 18 is I times the square root of positive 18. The square root of a negative, the negative comes out as an I. That's the easiest way to look at it. So now I'm going to combine things together. Now I'm going to say I to the 9th times I to the 1st times I to the 6th times I to the 1st. That could be 9 times 9. Remember, we add the exponents. 9 plus 1 is 10. 10 plus 6 is 16. 16 plus 1 is 17. So it's I to the 17th times the square root of, multiply those two together, square root of 36. So it's going to be 6I to the 17th. And now I go to my rules about I to the 1st equals I to the 2nd equals negative 1, I to the 3rd equals negative I, and I to the 4th equals positive 1. And I to the 17th, where does that fit in here? It's an odd number, so it's going to either be I or I to the 3rd. And what we do is look for multiples of 4. In this case, 16 is the closest one. And since 17 is one more, it's the same as just I. So that's going to be 6I would be the final answer to that one. Okay. We're winding down. Well, not quite. We've got a few more to go. This is just product means multiply. So I'm going to multiply 3 minus 4I times 2 plus 3I. And when I do that, I'm going to use my FOIL method. This time I'm going to use the word FOIL because some of you do like that. The first numbers are going to be 3 times 2, which is 6. The second numbers, the outer numbers, would be 3 times 3I, which is 9I. The inside numbers are going to be negative 4 times 2, negative 4I times 2, which is negative 8I. And the last numbers are the final two. So that's going to be negative 4I times 3I. Cancel that. Let's go back to there. Sorry about that. 3I, which is 12, negative 12. Negative 12I squared, or positive 12, because negative 12 times negative 1 is positive 12. So now I'm going to combine the terms together. That's going to be 18 plus I. Okay, 6 plus 12 is 18. And 9I minus 8I is 1I. So there's my answer for number 11. Number 12, the conjugate is actually one of the easiest problems. What we do is we just copy this down, we change the middle term, change the sign of the middle term, not the first term. So the answer is negative 7 plus 4I square root of 3. And that's what we have for that one. And now as I move on to the last two problems we have, again, this one has an I on the bottom. I'll rewrite this here so I can work with it. 7 over 3 minus I. What I'm going to do is multiply top and bottom by the conjugate of 3 minus I, which is 3 plus I. So that becomes 21 plus 7I on top. And the bottom becomes 3 times 3 is 9, and then plus 3I, and then these guys are minus 3I, and it's going to be minus I squared. So these cancel out, and I have 9 minus negative 1, or 9 plus 1, which is 10. The bottom of my fraction is 10, so that's going to be 21 over 10. Minus 7 over 10I. That would be the correct way to write the final answer, A plus BI. This is A, this is B. And the last problem is probably more confusing than most. This is going to be, if I look at this, let's write this here, 2 plus I squared of 3 over 1 plus I squared of 3. It's the same principles, it's just the problems get a little bit more complicated. conjugate, we multiply by the conjugate of the denominator. So that's going to be 1 minus I squared of 3. 1 minus I squared of 3. And now I'm going to do two things. First, I'm going to do the numerator. And that's going to be 2 times 1, that's 2. 2 times negative I squared of 3 is minus 2I square root 3. Then these two together, is that's the outer, then the inside is going to be 1 times I squared of 3, so plus I squared of 3. And the last one is going to be minus, now this is going to be tricky, let's just figure this, I times the square root of 3 times negative I square root of 3. That's what the minus part is. So that's going to be negative I squared times 3, and I squared is negative 1, which makes this plus 3. Because this whole thing here, the outer, this number here, times this entire number here, is negative I squared times 3, which is negative 1 times 3, which is positive 1 times 3, which is 3. That's what we get from the top. Now the bottom, we're going to do 1 times 1 is 1, and then we're going to have minus I squared of 3, and then the two inside numbers are plus I squared of 3. And then the last one is minus 3I squared, which is basically plus 3. Because I squared is negative 1, so it's plus 3. Negative 1 times negative 3 is plus 3. And now I simplify the top by saying 2 times plus 3 is 5. And then these two terms here combine to be negative 2 plus 1 is minus I squared of 3. And the bottom of the fraction is these are going to cancel. They always do when we use conjugates. 1 plus 3 is 4. So the final answer I would write for this is 5 over 4 minus the square root of 3 over 4 times I. That's 3 right there. And that would be the final answer to the problem. I hope this helps a little bit. It's a little confusing, but if you stop and go through it, it will help you quite a bit.